name is Mikey. As my work sample, I would like to present my project on CSOs, or combined sewer overflows. Let me show you how it works.
This is a model of a CSO. This house represents the household sewage pipe, and this represents a storm drain that collects rainwater. Both of these pipes go into the wastewater treatment plant, which takes some time to process the water. If there is too much water, it will spill out through this overflow hole, which is called a combined sewage overflow hole, as this sewer system combines sewage and rainwater. All the water that gets to the bottom of this box goes directly to the Hudson River, whether that be through the treatment plant or overflow hole. When there is light rain, a decent amount of sewage is produced. This is represented by the yellow sprinkles. As you can see, none of the water overflows and the river stays clean. When it rains, however, the combined amount of sewage and rainwater goes above the maximum water level because the wastewater treatment plant can't process all of this water at once, and so the sewage and untreated rainwater spill out into the river. The sprinkles that manage to make their way into the river symbolize the pollutants that harm marine animals and us. I got into this topic when my science teacher assigned my class a lab report on CSOs, and I connected this to what sometimes happened to my family's house. It flooded on rainy days because the water had nowhere to go. I got super interested and wrote a 26-page lab report. Then, I decided to continue researching CSOs for the Hudson County STEM Fair. For my project, I found a CSO outlet near me and collected water samples before and after rain to check if a rain event triggers spikes in fecal contamination, proving that CSOs are actively affecting the Hudson River. I put 10 microliters of each water sample on special petri dishes with a nichrome loop which I burned before for sterilization. The agar used for the petri dishes was McConkey agar, as it only allows gram-negative bacteria, like fecal coliforms, to grow. After 24 to 48 hours on a heating mat, I counted the amount of fecal coliform colonies in the samples. My data showed that on average, 1,000 more fecal coliform colonies per 100 milliliters grew after rain than before. This proved my hypothesis and led me to try and create a solution. As replacing the entire city's sewer system isn't an option, I designed a storm drain that uses a mesh net to stop trash from entering the sewer and wipers to prevent clogging. Also, educating the residents to avoid using water services during rain periods could help reduce the amount of sewage coming in.
As part of my research, I met with the chief engineer of the Jersey City Municipal Utilities Authority, Richard Hitches, to learn more about what Jersey City is doing to address the issue, and even delivered a TED Talk on CSOs for my school. I got a silver medal and a Thermo Fisher nomination at the STEM Fair.